Welcome back to Teach Me Now, and we're going to do another video on acids and bases, grade 12. So, a lab technician wants to determine the concentration of HCl. He adds 5 centimeters cubed of HCl sample to 495 centimeters cubed of distilled water to give him 500 centimeters cubed of dilute HCl. During a reaction, 50 centimeters cubed of this dilute HCl reacts completely with 0.29 grams of sodium carbonate. Okay, and the balanced equation is given. And we are asked to calculate the concentration of the hydrochloric acid sample. So in a way, we are working backwards. So this is what we need to calculate. So we added 5 centimeters cubed of this in here, and then it amounted to 500 centimeters cubed, and then we took 50 centimeters cubed of that and put it in here. Okay, so now let's try to calculate the concentration of the HCl sample. Okay, so we can work with what we are given this far. So we are given the grams of sodium carbonate. So we can easily go to moles from there. So we can say number of moles of sodium carbonate equals to mass over molar mass. And the mass is 0.29 as given. The molar mass you can find on the periodic table, which has a total of 106. And remember, when finding your molar mass, you have Na2. So whatever the molar mass of sodium is, you're going to multiply it by 2, and then you're going to get the molar mass of carbon. And then when you get the molar mass of oxygen, you're going to multiply that by 3. And then it doesn't work when you have something like this. You don't multiply when you have something like this. Only when it's a subscript, not on the side as a balancing number. Okay, but either way, let's continue. Okay, so the number of moles we have here would be 2.74 times 10 to the negative 3 moles. Okay, now that we have the number of moles of sodium carbonate, we can use the ratio of that and the HCl to get the number of moles of HCl. And we can see from our molar ratio that for every 1 sodium carbonate that we have, we need to have 2 times that for HCl. So our HCl would be, number of moles of HCl would be 2 times this, therefore it would be 5.47 times 10 to the negative 3 moles. Okay, now that we have our number of moles of HCl, which are in here, this means that we added this amount of moles in here. So this is the amount of moles which were in here. So we can work backwards again. Okay, so to find the concentration of the HCl in the distilled water, so our number of moles were 5.47 times 10 to the negative 3 divided by our volume. But now remember, our volume was 500 centimeters cubed when we added the HCl. And we have to write this in standard units, so we have to write it in decimeters cubed. So the concentration would be 0.1094 moles per decimeters cubed. Okay, now this means that this concentrate, so what is actually happening here, you have the HCl sample, so this is just HCl, and then you have your distilled water over here. So we are taking this concentrated HCl and adding it in the dilute water, in the distilled water, so that it can be diluted. So if you remember, you can use Na is equals to CaVa over Cp Vp divided by Nb. Okay, so this is what we are using, because we were actually diluting the HCl. But now this is going to, the Na over Nb is going to give us a 1-to-1 ratio. So that's just going to be 1 equals to CaVa over Cp Vp. So we can just rewrite it as Cp Vp equals to CaVa. Now we can substitute, and we are looking for the actual concentration. So this would be the concentration of the acidic part. So we don't have Ca, so we can divide both sides by Va. And for Cp, we have 500 centimeters cubed. And then for the volume, we have 500 centimeters cubed. And I'm going to write the concentration here, which was 0.1094 divided by the volume which we had initially, which was transferred, which was 5 centimeters cubed. So divided by 5, and then you should find that Ca is equals to 10.94 decimeters cubed. Moles per decimeters cubed.